soon enough.
Okay, so
Over under.
I'm going to go through the, make sure you do, virtual students, make sure you do your welcome check and put your problems on the board. We're going to go through worksheet number 2. So notice this car is at the bottom of the hill, so you need to make sure you use this force diagram. So don't be afraid to draw this force diagram right here. These are the force diagrams you need to learn. So please learn these force diagrams for all these different scenarios that we drew. We took notes on that the other day. So let's look at number 1. So here's number 1. Zoom in. Here's our force diagram. Anytime you're at the bottom of the hill, you need to make sure you remember that. You should always mark that your acceleration is going towards the center of the circle. And since you're at the bottom of the hill, the center of the circle is right there. Do you see it? Your centripetal force is actually going to be your force normal. So you should also write that down. So yes, the magnitude is constant, but the direction is changing. That's your velocity. Here is our force diagram for D. Then E, you actually had to do a calculation, so let's see how you did.
Yes, sir.
So you just take your force, centripetal force, you have your mass. And remember, since this is the only force right here, that's going to come over to the other side, and so this right here is your net force. That's going to go down here, okay? And then you have to actually figure out your force normal. So the centripetal force that's making you turn in a circle is this right here, and this is the confusing part. Everybody thinks that since we're writing the C right here, that this is our centripetal force. That is not the case. This is our net force. Whenever you have a net force, when you're going in a circle, you're going to do this calculation, and that's going to go right here. And then you're going to sum your forces just like we always do. And this is the answer you should get for F. Do you have any questions on that? So make sure you write that down. FC is not your centripetal force.
It equals your net force, right?
It is the net force. Okay? It is the net force in a circle. What's causing it to go in a circle is the unbalanced force, which in this case is the force normal. And that unbalanced force changes depending on your situations. So then we go on to situation number 2. We're at the top of the hill. Here's our force diagram at the top of the hill. Our center of the circle is way down here. And then we have to do a little bit of conversions here. Your calculator does these conversions for you. Did you know that?
Really?
Yeah. Let's see if I remember where it's at. So you have a TI 80, TI this, right?
Yep.
Okay, so if you go to
I think I have an 85.
well, then you're even cooler than me.
Is yours like the color one?
Mine's not color. I'm not that cool.
Love is blue.
Yeah.
Mine's
No, mine's an 84. 84 CE.
Yeah.
So if you
colors.
go second, catalog. No, that's not it. It's around here because I found it the other day.
I'll Google it. What is it? We're trying to.
Conversion factor, conversions for This will do conversion factors.
Conversion.
Is it under apps?
Yeah, where's that at? Okay. Click. Apps. There it is. Thanks, Logan. You are earning your little prize for the day. So close. So if you go to Science Tools,
Where is that?
you have a sig fig
Oh, I have it.
calculator and you have a unit converter. So that's what you would do. Unit converter. And you can convert anything. So we're converting velocity. So you push in 6. And we're going from kilometers per hour to meters per second.
Oh, so you type in the number.
See how you did that?
43 kilometers. Oh my
That
goodness.
is lit. That is awesome.
Okay, and you actually have a periodic table on here.
Oh, I
too.
did my conversions wrong. Whoopsies.
So you also have a periodic table on here. I don't know how to go back. How do I go back out?
Second quit. Just keep pressing until you get to home base.
Oh, look at, they have constants. Ooh, yay! Look at all your constants. So if you ever have a constant that you don't know, like look, G. Let's say you're taking a test and you don't know G. They're all stored in your calculator for you. Here's the mass of an electron. Here's the mass of a proton. Mass
So
of
it'll
a
tell you what the number for gravity is?
Yeah, it's right there.
That's awesome.
There it is. Do you remember?
Why did I not know this?
I feel like they should give us a calculator crash course.
Yes.
Like,
I
come
would
on.
so take that
Look
course.
at here's the speed of light. Do you remember
Jeez.
doing your calculation in chemistry? 3 times 10 to the 8th. There's the speed of light in a vacuum. I don't know what mu is. Mu here, oh, it's the atomic mass unit. Oh, cool. There's Planck's constant. So here are your chemistry ones right here. Those 3 you use for chemistry. Like this is the chemistry block right here. All the rest are physics. Okay. So that is your calculator. And then if you're ever doing sig figs, you have a sig fig calculator that does all the sig figs for you.
That is.
Then you might definitely use that in college. I haven't checked out the data and graphs wizard or the vector calculator.
Oh, vector.
That
Oh, yeah.
that might be pretty high level because that would be 3-dimensional vectors.
Oh, yeah. No thanks.
So there you go. Okay. Is that fun or what?
I feel so smart now.
And there's actually a periodic table on there too. So you have a periodic table on your graphing calculator if you ever need that. And I forgot where that is, but it's in that area of science. Okay, what do we got here? Then we figure out our net force. Do you agree with my number?
Mm-hmm.
And then we're going to put it into our equation. We're going to sum our forces. And here our centripetal force is the gravity, but we want to find our force normal. And that ends up being 4,916. Okay, then we turn the page and life gets a little bit more complicated. That's pretty complicated. Obviously, this is the force diagram for the first one right here. This is the first part. The friction is on the tires is what's going to be the centripetal force there. These are going to be equal, so we're only going to look at the x component. But then when we put it on an incline, life gets a little different. Do you remember me teaching you? You have to study this. Your force normal has to be broken into parts, and you have to sum the parts that are going towards the center.
I have a question.
What's that?
Does it matter if we put the triangle part on like the Y?
Yeah, because I did that too.
Going like up the Y and then over the
Like
end?
this way?
Yeah, so like my triangle looks like this. It's like upside down. Just because that way I have the Y on the... Or does it have to go down?
I think it has to go down. You drew one that was going like this. So do you see how the car is tilting this way? It's tilting this way.
But on the picture it's going like this.
Okay, so you gotta think when you're looking at it, where's the center of the turn?
On this side.
So that's the way so that is how I remember how I'm gonna go towards
so you bring
the
it
triangle.
towards the center of the turn.
Yeah.
Okay.
You're gonna break down the triangle and go towards the center of the turn. That's what I'm trying to say.
Okay.
The other one we drew was the other way.
Okay.
So maybe I should have done a better job of explaining that when I did it.
So basically, if the center of the turn was like this way,
Then yours would have been right.
then it okay. I will write that down.
Hunter, how are you doing out there? Good?
Yeah.
Okay. Alrighty. Number 4 should have been easy for you. Number 4.
There's no problem.
Number 4 looks like this. So the ball at different spots is going to have a different force diagram. So this is at the top, this is at the sides, and this is at the bottom. Keep in mind my force tension here should be a lot shorter. It's not drawn to scale. Notice both of these are acting towards the center. And the confusing part for people is why doesn't the water fall out of the bucket, or why doesn't the yo-yo hit you in the head? Do you remember why? Logan's favorite word. Inertia. Yeah. Because it's going to keep going in a straight line and it's going to hit the side of the bucket. And that's going to force it to go down. Okay? And it's going to keep getting pulled in by that tension. So your centrifugal force that's causing it to go in a circle is your tension. Only the tension is acting towards the center. Okay? Does that make sense? And that does it for worksheet number 2. So now we need to work on worksheet 3, and we're going to do worksheet 3 together. That sound good? Worksheet 3 is kind of nasty. So I'm going to go through this one with you. So we have a woman that is doing some aerobatics, and she is going in a circle. Okay? So notice how what I added to the circle. I have the center. I made the line. So that way if this force right here, whatever it is broken, she'll end up going this way. Okay? So the radius of the circle is 380 meters. She's going this fast, so we're going to have to change that to meters per second. And she has a mass of 55 kilograms. She's going this way, so I need to draw a force diagram for her. So there's her force diagram, right? This force diagram is the same as what? The the force diagram of the yo-yo at the top of the yo-yo pack, right? Do you want to draw this? Then, after we get our force diagram drawn, what is our next step going to be?